Alright, welcome back to the channel, everybody. It's the next day. Took off work a little early because I can. Nice to have a job with the flexibilities. Anyway, let me make sure this is right. Working on this Silvertone again. And, you know, at first glance it didn't look like it was too bad in here, but there have been some changes. There has been some stuff that has been done inside this radio. Of course, what is it, 49, it's about 70 years old or so. So the candome, part of the candome resistor is bad. You know, we determined that last night. Got a couple of little bit, some Allen and Bradleys in here that a little bit different than what this radio was designed to have. At least that's how I suspect. And I see this right here, these resistors network right here, that don't look factory. There's a capacitor down here that don't look factory, so I got to make sure what it is. I've been sitting here just spent about an hour so far just trying to figure out what exactly is going on here. And this set reminds me of the Transoceanics, or the little battery powered sets. And they had capacitors, bypass capacitors on the filament. And it finally dawned on me that they are direct heated cathodes on most of this stuff. That's why these 1L, these low voltage tubes are, you know, they're directly heated cathodes as far as I can tell. I'm not 100% sure about that, but they may or may not be. I'm probably wrong. When I think about it, they may be indirectly heated cathodes, but anyway, they have bypass capacitors on there. So anyway, this is the rectifier socket right here, and I was trying to figure out what this pin 3 was. I know it's a test point because that's not a the tube doesn't have any internal connections to pin 3, so it's a test point. So it's actually ground. So this capacitor right here goes from the electrical ground, and the other side of the capacitor goes to the chassis ground. And it took me a little while to find it, but it's that little dude right there. It's a 0.2 microfarad at 200 volts. So I guess we'll put a safety cap in there for that, I guess. So okay, now that I figured out what was going on in that section there, it was kind of like, it's just kind of strange looking. I believe this capacitor down here is a different type than the rest of them, but it's can be in, I don't know if you can see it or not, but it's been, I think this is an aftermarket, if you will. It looks like the filter capacitor has had a little work done to it, because this leg right here completely missing. I have no idea what was on there, so I was trying to find that. So this may, that's the next thing. I got to find out where that went, where that disappeared. It looks like they might have just bypassed it. So I got some things I got to change in this radio. But one thing I was going to mention is one of my viewers noticed something that I didn't. I kept looking at this radio thinking something's strange about it, and until he said something, I didn't catch what it was. But it's right here. This does not have a gain capacitor in it. I think they call this a reactor type tuning system. It's kind of like a car radio. But there's your tuning stuff right there. It's all adjustable coils. It's got, when you tune it, see if I can make a little room in here. The light. So I'm going to tune the tuning dial. And you'll notice that these plungers go up and down inside these coils. There's two on that side, two on the other side. Reactance tuning. So kind of a unique set then I have on my hands here. So anyway, I'm trying to figure out the wiring on here, where the capacitor's missing, but I'm going to order what this capacitor says it's supposed to be, and I've already got a list for the other capacitors over here that I need, except for this antenna cap here. I got to do that. But I got the capacitors here. I'm fixing to get this value, write it down, get the values for that. I'll do a restuff on this one here, and then I'm going to check the circuits a little bit more. I think I have enough resistors to fix this, so I'm not too worried about that. I'm just going to kind of leave some of it alone until I get it powered up to see how it works. So the next step that I'm going to do is I'm going to test these primaries and secondaries of these two IF cans here. I will tell you that the IF cans are 455 kilohertz, which is good. So that's the next. I got to identify this, so I'll get this set up, and I get the camera in an angle that we can look at the ohm meter, and we'll go ahead and test these two IF transformers. So be right back. Alright, here we are in record mode again. I've got set up best I can to get where I can see the chassis and you guys can see the chassis and also see the ohm meter. So now let's figure out where these transformers are. And this is one here with a bunch of wires going in, and I think this is the second one back here. So we just got to identify where it actually goes. So I'm going to get the schematic out here, and it's got 4 leads on each one of them. So I think we'll do the easiest to get to one first, which is this one here, which should be the second IF. And without my glasses, I can't hardly see that. Let me get my glasses on. It says 78, so it's A2 and A1. Right there's the one I'm looking for right there, so that's what we need to do. So what I'll do is I'll check the plate first. So the easy way to check that is do it a couple of different ways, but I think, let me see how I can do that. I need to find the 13 microfarad filter cap. So let's see. It looks like it says 13. I can barely read that schematic. It's writing on it, horrible. I'm a flashing light, or torch as the Brits say. So what do we have? We have an 80. I'm gonna read this stuff. It looks like 2 80s, a 100, and a 40. Yeah, well, that's what it says. That's what it says. I'm just telling you what I see. Let's do it a different way. Let's just find the plate of the tube that this A2 connects to. So it's going to be pin 2 of the third tube. There's 1, 2. This is the third tube, so I'm looking for pin 2. So looks like it's going to be right there. So we'll do that. Alright, so we've got to find the other side of it, which I'm going to say, I'm going to take a wild guess that this is it. We've got 12 ohms. I just took a lucky guess. That looked like it was going in there, so it looked like a B+ point. So I've measured 12 ohms from the plate through A2 to this side right here, which is tied to this B+ rail. Okay, so let's see what the let's see what it says on the parts list. Let's see, transformer, RF coils. Let's see. Let me find it. Bear with me, boys and girls. Let's see. Input IF. Just says 10.5 ohms, so I assume that it's going to be 10.5 ohms input. We have 11.9, so that's good. So, and I'm thinking that the secondary is going to be the same way, which needs to be look like pin 4 of the fourth tube. So the fourth tube should be this one. So let's find that. Tube 4 they call it. So let's find pin 4 of the fourth tube. So that's going to be 1, 2, 3, and I don't see nothing on there, so it looks like it's right there. This looks like it's been doctored on. I think it has. Anyway, there's that. Let's find the other side. Other side goes down to one side of the volume control, looks like. So let's see what we can do there. That says 72.4. So 72K, I'm not sure about that. I'm not sure I got this going on right. There's a green wire going in there. Let's see. Man, I can barely see in this tight son of a gun. Like a green wire going in there. There's a 47K resistor. Oh, duh. Okay. Forgot there was a 47K resistor in there. There's a 47K. Let's see what it does. Man, I can't hardly see anything in here. Yeah, I'm pause you a minute. Okay, it took me a minute to wrap my head around what they're doing here. The schematics are great, but man, they are really cryptic. But anyway, back on the secondary of that second IF transformer right there. This guy right here, it's called 76 on the schematic. Anyway, from the detector part of the detector tube, detector slash preamp, one side of the secondary goes to it, that would be pin 4. The other side goes through this network here. It looks like a 47K with 275 picofarad capacitors, or microfarad. Anyway, and then it goes to the volume control. So I found a lead right there, if you can see it. It comes up right there, ties to this test point, and then it comes back down to the volume control. That is the lead, and it measures 73K or 72.7 kiloohms. So we may have a problem internally with that coil, not the coil itself, but that 47K resistor. Say 47, that would be about 27K resistance, DC resistance. I'm not sure if that's right or not. Why? Because the print says, it doesn't tell me anything about it. It doesn't tell me what the resistance is supposed to be. And I can barely read this. It says R15, but it doesn't tell me what it is. It just says, and I got to remember, it says 47M. don't think M means meg on these old schematics, because if it was meg, it would be MEG. I got to remember that. I don't remember what the 47M is. It's got to be 47K. So if it's 47K, and I'm measuring 73K, what's that make it, about 30K, somewhere thereabouts? So I don't know. It's some kind of continuity in there. Let's move on. That's getting me down. Let's see if we can figure out this other dude now. See how complex and hard to find it is. Again, I can't hardly read these schematics. So the primary of the first transformer, they call it T1 in here. So anyway, the primary is between pin 2 of the second tube, or tube number 2, whatever. And it goes to the same place this other one is. So let me set that up here. And I'm going to go to pin 2 of the second tube, which is almost impossible to get to. I'm going to cross my fingers and thinking that that's it right there. Or maybe not. Well, this set's being a dog. I'm about to have second thoughts about repairing this one. You what? Let me get a different test lead here. Something I can pierce with. Yeah, by George. Now we can do something. Alright, so we got 0 resistance there. Did have, let's make sure. Alright, let's go back up here to what I thought was pin 2. Of course. I kind of hate it when my little clip leads go snap. Go flying off like crazy. This thing's all jacked up. Hey, here's another one for the garbage can. Nothing aggravates me more than a cotton picking clip lead and go snap, comes off. Try this again. We got one that ain't broke. Alright, it said pin 2. Did I read pin 2 or am I just hallucinating? Yes, pin 2. Can't. Everything is just not working all of a sudden here, and it's really trying my patience. Oh man. Well, let's try this pin right here. I can't read. There it is. 17 ohms. Okay, that's cool. I'm good with that. Alright, so now let's find the secondary of that transformer. Again, I'd love to have a decent schematic. It says here the secondary, oh boy, there's a 15 meg in series with that internally, I think. So anyway, pin 6 of the third tube. So 4, 5, 6, and it's way back here in this back, way back in the back. Alright, got that, at least I think I do, and then we're going to go back, circles back around to pin 8. 6, 7, 8, way back in the bowels of this thing. Make sure I got a connection, which I do. I don't read anything, y'all. Not a thing. Go over to this side. There we go. Showing about 12 meg, if that's it. It's got to be it. I'm showing 12 meg. I got something through there. It shows a 15 meg 15 meg in series with that secondary. Man, I don't want to pull these coil. Jeez, man. I can see the nuts on, I can get to the nuts on that one a little bit better than I can that one. If I could just get the cover off, I might be able to do this a little better. I have a feeling the resistors are out of tolerance. So let me get my 1/4 inch. See if I can do this very carefully. After all, this stuff is over around 70 years old. I don't know what to expect besides chaos, destruction, and doom. Let me get some precision to get in there and hold that with. Get the tweezers out here and just get down in there and grab it. Star washer in there. So I can get it out intact. I don't know if I can. I'll just have to do it. I'll just have to wing it. Let's see if we can get this one out. Don't know what to expect. It may not want to come out all in one piece. I don't know. I have a feeling I'm about to say sayonara to this project. Yep. It ain't gonna come out without me taking it all apart. Ah, phooey. Well, at least I can identify where the leads are now that I can move this thing. Tell you what, if I got rid of that capacitor right there, I could see this a lot better. No telling what else I cut just then. Get out of there. It's a really cool looking capacitor. An old Sprague 600 line, working voltage 600 volts, 0.01 microfarad tubular condenser. Really cool old capacitor. I had to put that in my relics. Alright, let's see if we can find that wire. Here it is right here. Here's one right here. Here is the other one, a dark colored wire. And then I have another coming over here, which is the plate, and then the other one coming over here. So I say let's just pull the cotton picking thing. So, I mean, we're already in here, you know. Let's do it to it. Heck, what the heck, you know. Find my phone so I can take pictures and make some notes. Always take pictures, kids. I wasn't going to show all this stuff. Oh God, no, not me. I don't think. It's gonna do me a lot of good with pictures on this one here. Alright, get my notepad out. Do an artist rendition. Let me turn the page here. Didn't know I was going to do all this today. So what I have, look like a brown gonna call it brown. I don't know what else to call it. Comes over here to 4, 5, and 6. Tube 3. Alright. Then I got a beige. Going over here. It's a junction point there. So let's get them two out of the way. I need my other needle nose. This wasn't supposed to take this long. You know, I think I've already overstepped my time frame on this video already. Make another picture because I got to take pictures of these components because I got to cut some components out of the way to get to them. Cut that little dude right there. Oh boy, that opens it up. What a mess, y'all. This thing's a mess. A mess. Alright, let me see if I can get in here and get this little sucker out of here. Alright, got one off. May have to get the desolder gun a hold of this one. There we go, I got two off. Good. Let me take another picture of exactly how that's routed, because anytime you pull this stuff off, you really need to route it back how it was. Let's see. Yeah, visual identifier here. Alright, 2 to go, I think. I know where one goes, I don't know where the other one goes. We'll have to get in your way a minute. Turn this just a little bit. Hate turning this stuff. Try not to move stuff if you can help it. You never know when this stuff is just yeah, this is tight. I think I got that one, so I'm missing one more. It's a ground right here. Didn't know what I was going to get into all this stuff. I thought this was going to be a slam bam, get in and get out of it. You know better than that though, don't I? Looks like I got them all. I hope. I kept thinking I'm missing a wire. There it is. One IF can. Woohoo! And you got this little clip right here. Holds the whole assembly in. So let me see if I can persuade it to unclip. Not sure, but I think push down on this just a little bit and push it in maybe. Remember, this stuff is unobtainium, in case you didn't know. Before I pull it out, I'm going to make a mark inside so I don't get this stupid thing backwards. Because if you know me at all, you know I'll get anything backwards. I also love to drop stuff on the floor while I'm doing videos and stuff. I had to stop everything and get down there and get it. Alright, here we go. There she is, guys. Woo-hoo! There's the resistor in question right there. Four wires, okay. So, let's go back to this black one, which I've got. Where's the red one? Get y'all in frame a little bit better. This thing's still recording. Alright, that one's going to be the primary. I think that one goes to one of these. Yeah, there's your primary. So here's your secondary. Secondary measures about 12 mega ohms. So this black wire right here goes over to a junction point, goes through this resistor to this coil. So let's move and bypass the resistor and go straight to this side. Junky Chinese leads. 11 ohms. By George, I knew it. So now let's move there back to here. Which one was it? Oh, these test leads are giving me a pain in the patootie. So we got 12 megs. Says it's a 15 meg resistor, so I guess I think we'll leave it alone. I think it's fine. Put it back together before I tear it up. So now we know. So now I'm wondering now about the other coil. Remember how it measured. Managed to get that back together. This little piece of brass here is corroded on one end, so I think I'll clean it up a little bit. Yeah, I can use Brasso or something like that, I guess, to do this. I'll be right back. I don't know how much of that last segment I'm going to have to edit. That turned into a can of worms. I didn't expect that. Maybe I did. I was just too stupid to know it. Anyway, I have determined that this thing is good. It's fine. What happens when you can't read a schematic good, as far as can't understand the writing on it, and your OCD. So the combination two, I pulled this out. But anyway, it gave me an opportunity to clean the coil, the aluminum off a little bit. I did have a boo-boo right there. I just got careless. I knocked that piece of tab off. Just don't do what I do, okay? I'm like a elephant in a china shop. I would say bull in a china shop, but Mythbusters proved that they don't tear up stuff. Anyway, if you trust Mythbusters. So anyway, I've come up to a crossroads in this project. It's one of those things where, out of there. It's one of those points in the project where you gotta like, what do I do next? So I'll show you. The chassis. Fly it out of the way. This is where I pulled that IF can. And this one's next. I'm undecided. I'm going to pull this one so I can make sure everything's hunky-dory in here. But the chassis itself needs to be cleaned. Now's the time. When I pull this can out, now's the time to clean it. I got to be careful because I got all these tags on the back that I got to do, and I'm also thinking about, I hadn't decided yet, pulling this transformer out. So that's where I'm at. Against my better judgment, I'm going to pull that other can out. Or I might just clean where this can came out, around this side, the one half of the chassis, clean from here over, put that back in, take this out, do from here to there. That way I don't have both of them out. I don't know. But I've got a few weapons in my arsenal to get that out of there. So let me work on that for a little while, and we'll come back sooner or later. Alrighty, been a couple hours. I've cleaned I went ahead and cleaned the corrosion off the chassis best I could, best that I want to do. If you can see that, I can't. I mean, it's still blotchy, but it ain't corroded. And as far as I'm concerned, for what I'm going to do with this radio, this is fine. I could go in here, take all this stuff off, sand all this stuff down, repaint it, and all that mess. What's the point? Nobody's gonna know but me. Hang on. Phone going off. Anyway, that's where I'm at now. We'll go ahead and put this IF can back in here and get that wired up. Then I'm going to concentrate on this one. If I can get it back in. I mean, take it out, clean it, make sure it's good inside, put it back in. Then I'm going to make some more tests of components, and then I'm going to order parts. And that'll be that. I don't know what else I need to do to it right now. Yep, that's what I'm going to do. So, y'all want to watch me put this IF transformer back in? Okay. You asked for it. Went ahead and let's see. Yeah, I messed up the cotton picking paper on it. I wasn't watching what I was doing and I damaged it. That really aggravates me when I do that. Really gonna be fun is getting these nuts on here and these washers. Make sure you give me a second. Let me get this stabilized. Make sure I'm still in frame. Yeah, I'm gonna have to get my glasses on, of course. If I can get these little tooth washers on. It's the first thing I gotta do. Alright, then I'm going to come over here for the nut. Yeah, I think it started. Let's see if I can get it on there. Cross your fingers, ladies and gentlemen. Yep, snugged up. Look at there. Did it. Woohoo! One to go. On this transformer. This is be real good for them people that's plays Operation, the board game Operation. This would be right up their alley. Man, did I get 2 for 2? I did. Got 2 for 2. Woohoo! Alright, now we got to figure out where all this stuff goes again. That connection there is pretty poor. So I think I'm going to get my desoldering gun out, clean that up. Get the right tip of this thing. And all the help you can get with these crazy things. So what I got to do right there, I'm going to zoom in so you can see what I'm doing. Right there. Make sure I got it in frame. I got to get that solder off there. It's kind of a mess. So I'm going to use my desoldering machine tool. Add a little fresh solder, 70 years newer to this. You'll still see right there. Bring it over just a little bit. There we go. Alright, yeah, it's got some stuff in there that needs to come out anyway. See if I can do this. Does a great job of cleaning stuff. Gives you that old smell of old electronics. Love that smell. Like Mr. Carlson used to, or always tells you, These leads here, you take a pair of really sharp diagonal cutters here, come into these leads, and you just use your diagonals. Don't cut them unless you have to, but you can use these to just kind of twist them off. Because I took a lot of the solder off this, which gives its mechanical strength, if you will. And then, like, here's a lead right here that I've got. Oh, where you at? That can go out. Alright, so let's see. Just kind of inspecting things. I'm trying to rearrange a few things here while I'm at it. Make this look a little bit better. This is the B plus line right here for the input to the primary of the IF transformer. There we go. Just move that lead down a little bit on that terminal strip. Now what I'm going to do here is I'm going to kind of break the rules. Some people's probably like cussing me out right now, but I don't care. I do what I have to do to make this work. And lead length almost not long enough. But I got enough to get it on there. Guess you guys are still in frame. There is a capacitor, I believe. There's some resistors there. I guess I need to test, but they're really high values. Let's see, that's a 680 ohm. That right there is a 1 meg. Guess we could check those. Alright, so let's see. Next one, this lead right here. Got to get down inside there a little bit. So I'll figure out how I can do that. There we go. Woohoo! Again, I'm going to clip that lead to make it a little easier to get in there because the ends of them are a little bit deformed. You know, I ain't going to be able to resolder these Heathkit style. You know, they always tell you how to bend your leads and all that to make it mechanically strong. Oh well. This one's fairly easy. This next one coming up, not going to be fairly easy. Alright, got that one done. What did I do with my solder? What did I do with my solder? I can almost see, huh? Right there, almost out of frame. It probably is once it gets converted over to MP4. Okay, let me have another look at that. I think that'll work. Better than some of the stuff I've seen in here. Alright, 2 down. Now I got a black one that's got to go back up in there. So let me go ahead and clean that out. Just going to tack that one in there because I'm going to have to pull it back out once I get the capacitors for this. That's the connection point for them right there. So this one here has got to go up. It's got to go up in the middle of this trimmer right here. This thing's got a pile of trimmer capacitors on it. There we go. Again, this one here's got enough lead length too much for what I'm going to do. You'll never get that back in there unless you just completely redo those leads. Almost there. Where'd it go? Like I said, I'll clean all this up when I get all the capacitors. So I got one to go, and it's way up in here, and I think it's right there. I don't remember if it's, I think it's on the, I think it's right here where I can get to it, pin 2. I think it is. Might be able to get that one back in there. Look at that. Fell back in there like it knew where it was going. That is amazing. I probably can't even see it. Let me see. Yeah, it's right here. Yeah, it's out, completely out of y'all's field of view. Moved up on y'all, didn't I? There we go. It's down in that hole there. All I can tell you. Yeah, that ain't wanting to go in too good. It's got a little blob of solder on it. I didn't notice until just now. Try to go in like this right here. Let's see if I can just knock it off a little bit. Now, see if I can get it in there a little better. Don't y'all wish y'all could see? I wish y'all could too. Not sure about that one. Clean this chassis with I use vinegar, a little bit of light wet sanding. Wiped it all off, did it again, wiped it all off, did it again, wiped it all off, and then I got some navel jelly and put on there, and put a little bit of navel jelly on there, and then sanded it again with a green Scotch pad. And it just went back and forth with that right there, and I finally just rinsed it all off and with a electronics cleaner. And I think it'll be fun. It looks a lot better than it did. Okay, I got that transformer in there, so I guess we want to do number 2. That's fine and dandy, except it's like a little bit harder to get to. Need to relocate my light, need to relocate you guys probably. Alright, let's see, here we go. This is our target right there, so we gotta go down. Alright, you seen me put that one in, and I know that bored y'all to tears, so I'm gonna stop the camera a minute and I will see what I can do to get that one out, and I'll come back when I get it out. Yeah, this thing is about as much pain in the posterior as I figured it was going to be. A little collateral damage on this one. Didn't want to come out. Sorry about that. Didn't want to come out. But it's out. Life is good. Moving on. make a boo-boo. Did y'all see it? Y'all see that boo-boo almost made? I did. Got to mark the orientation. There it is. Whatever it's worth. 47K resistor in this one. Yeah, I'm going to have to probably replace one of these wire leads in here. Anyway, let's measure it. Widen the field a little bit. Get y'all up here where y'all can see. There we go. Alright. I want to measure this 47K, which is a yellow, violet, orange band. Goes right there. At 47K, measuring 72K. There, that's why I wanted to pull this. That resistor is bad. So let's see. Nine and a half ohms. There was my primary, my secondary right there. 9.5 ohms. That's better. That's what I wanted to see to begin with. So it was worth it to pull this out because I had a bad resistor in there. So I'll change it, but let me bring you back because I got some prep work to do. Alright, I figured I hadn't bored y'all enough. I figured I'd just go ahead and see if we can get this resistor out. Ain't like we're working on something that's unobtainium, you know. Story of my life, I guess. One 47K, or excuse me, 75K resistor. Let me see if I can find another one. Alright, got one here. Came out of an old box of ohmites. Let's see how it measures, just in case. Yeah, it measures 49, close enough. My boy used to tell me, close enough for government work. Yep. See if we can get it in there now. Close-up glasses back on so I can see what the heck I'm doing. Give that just a slight bend. There we are. You see that clumsiness I just did? hope you. I sure did. I'm just clumsy, man, in my old age. I don't know what it is. Alright, now this other one here, the lead came out. Which is just in here, but I think it's long enough. Back in and see where it came from. That is how I found it. Let's remeasure everything in this transformer. Make sure it's still working. $49.5K. Alright, that's them two. And then I think this black one, I don't remember what this black one does. So, transformer chest good, but I think this one was a little pain in the butt. I'm thinking I'm having to change this green wire and this green wire. That one was a tight little dog, and it went up in here to the grid of the detector tube. But this one here, which I may have to lengthen that one. Let me see if I can find one to lengthen it with. Alright, I just used my Remington number 20 gauge hookup wire right here. Pretty cheap price, forgot how much I paid for it. It comes in handy. It ain't cloth covered, but you know what? Cloth covered was all they had 70 years ago. And I got this and it'll work just fine. If I get an F for that, oh well. Electrons don't care. They don't go through wire anyway. They just travel on top of it. Right? Right. Glad we agree on something finally. So I got the resistor changed and all that other good goobly gook stuff. The next thing is this can. I was going to clean this can, so I guess I ought to do that. It's a little pitted. We're going to give this some love. Alright, there it is. As clean as it's going to get. I had to add a couple of leads to it to make up for some differences that I messed up in here. So the next thing I got to do is go inside here again and clean up a mess that I made getting all this mess out. So, be right back. Oh my word. I think I got this dude back in here. Let's check it. We'll check the secondary now. Bring you up a little bit. Ah, come on there. Wind it up a little bit. Secondary should be about 75,000 ohms. So let's see, that would go here. I'm sorry, not 79. About 50,000 ohms, because it's a 47K resistor. So, okay, that checked good. That's good. All right, now we need to go to, excuse me, the primary. Primary should be about 12 ohms, and it is 12 ohms exactly. All right, that was a successful repair, if not mind-bending, if you will. So I had to remove a couple of capacitors. Had to remove this one here, old 5 at 200. It came in from right about in here to be able to get to the nuts that held the can on. This one, so 0.01 at 1200, that was the antenna cap right there. I just pulled it off so I could clean under it a while ago. That one came from over here. This one came from, I forgot, somewhere over there. Got a lead here that's come off of something. I don't know where that came from. I don't remember taking that off. Huh. I'll figure it out later. Anyway, there it is. Yeah, I know the blotches are there. Honestly, ain't hurting a thing, and this is a freebie. Yeah, I could go in there and do a little bit better, I guess. But I think it'll work. So I just need to sit down and figure out what parts I need. Oh, I'm going to do a resistance check on some of these resistors too. So let's do that. Let's do a resistance check. How about that? Good old resistance checks. I love them. So what do we check first? I don't know. We'll just grab some. Let's see. There's an 820 ohm resistor. 1178, so that one's way out of tolerance. Here's another 820. That one's closer. It's about 860. That's okay, I guess. And here's a couple of hodgepodges right here. It is a 470 ohm resistor in series with a 150 ohm resistor. That one checks 493. That checks 155. I mean, I don't see really a problem with that other than they're old resistors. There's like another 470 ohm resistor right here. Oh my lord, that thing's at 990 ohms. That's a bad one. This is a like a 6.8 meg measuring 7, so that's good enough. I'm okay with that. 47K measuring 54. Here's a 1 meg measuring 1200. I mean 1.2 meg. Here is a 680 blue 6. Yeah, that's way out of tolerance, measuring 815. So what else here? Here's another 680, looks like. Way out of tolerance, unless I forgot how to read a resistor. Here's a 68K measuring 64.5. That's fine. Let's see. I know there's some more in here. Here's a 2.2 meg, I believe, measuring 2.6. Here's a 3.9. Yeah, it's either something measuring against it or it's low. Usually they go up in value, they don't go down. There's a 33K right here. Let's check it. Measuring 31K. Not bad for this old radio. Been joking there somewhere. What else? So I need to make a list of these resistors. I'll go back in and recheck them again, but I'll investigate this Candone business here to see. I'll get the radio, I'll get it working, and then we'll go back and we'll measure the current flow through that part of the circuit, and then we'll figure out if that needs to be changed to a little bit better. We're just going to do it that way. So I'm going to get my list out, get the resistors and everything that I need ordered, and that'll be that. Let me see, what else? I tested all the tubes this morning. I had one other tube measured weak. So we got a rectifier tube. Yeah, here it is right here. It's a 7B7, 7 Bravo 7. It was actually over here in tube number 1 spot. I think it's the RF amplifier, if I remember right. Supposed to be in a 1LG5. I don't know if that's a substitute for it or not. And I think I saw a discrepancy in the wiring. That's like this tube. It's been rewired for this tube. Just the way that socket looks on the other side here. And I'm trying to find my other schematic. Yeah, 1LG5, the RF amplifier. This is a 7 Bravo 7. It's a Philco tube. I don't know. I guess I ought to look these up, see what the differences are. Let's have a look under the hood here. Yeah, that tube's weak, so I got to replace it anyway. So that tube, I actually spoke out of turn. Actually, that tube. Wait a minute now. I'm confused. 50A5. Let me get my 14A7, 14B6, 14B8, 14B8. Now this is now I'm confused. 14B8, manufactured 8 of 48. Oh Lord, shows you how much I know, right? You look at the tubes and see what the crosses are on these things, because it's not the tubes that's supposed to be in here. Well, something's wrong. Besides my thinking. Well, alright, so none of these tubes match what says it's supposed to be in there. This is a 14B8. I wonder if this thing's been converted. I don't know, I'll have to research that. I don't know what the hell I'm talking about. I'll be back. Well, it's my bodkins. I got totally thrown for a loop. I didn't even realize. But this radio here, I don't know why I didn't realize it. But all the tube complements were calling for 1LG5, 1LC6, 1LC5, 1LD5, 1LB4, and a 35Y4. Okay? I mean, I saw it on the cabinet. I saw it on the schematic. But when I was looking at the tubes, it did not dawn on me. Like here, for example, here's a 14A7. Alright, the 14A7 was in the place of a 1LC5 IF amplifier. Okay, the 1LC5 runs off a 1.5 volt filament. The 14A7 runs off a 12.6. Every tube in here, other than the rectifier, has been changed to accommodate 120 volts or 117 volts AC. I find no reference to that, but it dawned on me, for somehow or another, this radio's been converted from battery operation only, from low voltage tubes, to higher voltage tubes, which apparently must be more reliable. It's my chart I came up with. And I didn't notice which tube come out of what, so I had to go back and say, okay, oh, there's a converter tube. Okay, well, my tube manual says, oh, that's a converter tube too. So I had to do process elimination and look it up, and then whatever was left, I was able to fill in the blanks. So now I know where my tubes go. Wow. Didn't realize it, y'all. Just didn't realize it. Oh, anyway, apparently there was a modification, I guess. I don't know. I don't know. Somebody knows these things more than I do. Tell me. Went from a bunch of 1 volt tubes to 12 volt tubes. And I think there's a 7B7 in there. 7 Bravo 7 is the RF amp, and it goes in place of a 1 Lima Golf 5. Wow. Almost completely went over my head on that one. Anyway, getting late in the afternoon. I wasted a lot of time on this thing, looking up that mess and not paying attention. So I think I'm going to get a parts list rounded up. But I think I'll just go ahead and I'll go ahead and process this video and get it out today. Then I'll work on the parts list. And then I'll go eat dinner. Anyway, that's that for this episode, guys. Hey, thanks for hanging in there. I'm going to probably try to edit this and get rid of some fluff, some junk out of it. Never too old to learn. I learned something I've never knew about these sets before, but it made perfect sense. You know, go from 1 volt tubes, 1.5 volt tubes, which is for battery operation, and it says in the tube manual for battery operation to go to the different type tubes, which I guess if you know your tubes, you know which ones to replace it with. But anyway, that's apparently what somebody did, is they converted this thing. I guess some stuff didn't work out. Too much dropping resistors giving problems. That could be what that candle was all about. I don't know, but let me process this video, get it out there, then I'll make a parts list and I'll order the parts probably next Tuesday, because I think they're going to be closed. It's too late to get an order out today, and they'll probably be closed Monday for is it Veterans Day? Yeah. Anyway, so I'll get the parts ordered if I can, get back on this thing. But at least it's clean now. Anyway, thanks for watching, guys, and I'll talk to you on the next episode. Hang in there, do like and subscribe. Comments, questions, whatever, send them to me. Talk to y'all later. Bye.